So now we will check that the remainder term for the function f goes to 0 faster than linearly. Okay. So what we want is to say limit as x approaches to a, the vectors, this guy we want this guy to go to 0. So let's break this up for a sec. Oh, and the norm. Draw the norm too. So what is this guy? This guy is the square root sum j from 1 to m of RAI for each component at vector x squared. That's what the numerator is. Then, by using a technique, assignment 1 question 3b, we have this inequality at our disposal. So now that's equal to sum from j equals 1 to m, RA for each component, take the norm, no square root. So to go from here to here, that's by question 3b of assignment 1. There's an inequality there. I'm using that inequality right now for the numerator. But we already know that. Okay, so then this is a limit, so you just play around with the limit. But we already know from before, by Taylor's theorem, this is going to 0. It goes to 0 by Taylor's theorem for each of the component functions fj. Their own remainder functions go to 0 faster than linearly. So they're all 0. That's just a sum of a bunch of zeros. So that's just equal to 0. And from here to here, I'll use red. So by Taylor's theorem, for each of the fj's, the remainder term goes to 0 faster than linearly. And that's it for this part.